Okay, look up. Okay, working on the P. As I said before, Unit 4 is all calculator allowed problems. The entire pink packet consists of previous AP test questions from the written section. So these are what are known as FRQs. An important thing to get used to with an FRQ, and this happens quite easily to be fair, is that with an FRQ they always give information followed by questions. So the format of an FRQ is information and then they'll have questions A, B, C, and D. Sometimes only A, B, and C, rarely just A and B. I've never seen just A. So anyway, so FRQ usually then followed by questions A, B, C, and D. So that means you don't have to keep rereading the information. The information applies to the subsequent questions. So here's a good example. This was given quite a while ago, but even though it's 19 years ago, it's extremely valid. It's exactly the kind of thing that still shows up on the AP test quite regularly. They give a graph. They describe the graph. They give some equations. And then they ask us to find the area of a region. So a big part of today's discussion is getting good at using the calculator appropriately and properly so as to avoid mistakes. So some of what I'm telling you isn't like calculus, it's just good habits that I found will help you eliminate mistakes. For example, when I have two equations, I've got to put them both in my calculator, and because this is the written section, I've got to be cautious to make sure I write everything I need to write. So what I like to do is look at the graph and identify which graph is typically above the other. So what I notice is this curve here, which is this formula, starts out above the other formula. So because of that, I'm going to make a note. I'm going to write on my paper, I want you to write the same thing. I'm going to write f of x is hereby declared to be 2 minus x cubed. And g of x is hereby declared to be tangent of x. So that's the habit I've developed, is I always write f equals and I always write g equals. And I pick the f to be the top function. Now I know these switch, but f does begin higher than g, so that's the pattern I'm trying to follow. Questions so far? Okay, next thing. Because it's a calculator problem, I want to be able to see this image in my calculator. So I always put into f, I always put f into y1. On the 84, you have an Inspire, you're going to put it into F1. And then I always put G into Y2. On the Inspire, that will go into F2. Okay, all eyes up here. Stop looking at calculator just a moment. You don't want to miss this. One of the rules of the AP test, which is a little bit strange, but it is a rule, they don't want to see you using this notation. It's not allowed. It's fine to do what I just did. I just made a little note to remind myself that f is going to be put in y1 and g is going to be put into y2. But in my mathematical equations, you cannot use the y1, y2 symbols. Not allowed. They'll take away a point. So don't do that. Questions? Cool. So now it is time to grab your calculator. Put those in like that. So go. There's a couple of people in the room that have an Inspire. If you need help with the Inspire, probably best is to, you both have one, that helps. You're sitting next to each other. If you need help, just wave at me. I'll come look at your calculator. Okay, we talked about earlier in the year that the way I like to get my graph adjusted is I like to use zoom fit. And so I always look at the problem to see if there are any clues as to how wide the window should be. When I did this problem the first time, nothing obvious jumped out at me. So I just went to my calculator and I do my standard guess, which is I'll select window. I will make x min 0 and x max 5. And then I zoom fit, which is zoom 0. It's been a while since we've done this, but wave at me if you need me to show that again. No one's waving. So this is the graph. Oh yeah, please.
Where is zoom fit?
So to do a zoom fit, the sequence is you've got to choose your window first. So I hit window, and I only choose the x min and the x max. So I choose the x min and the x max. I choose this one and this one. Then I choose the zoom button and press 0. Points for Autumn. Okay, the graph obviously does not match the picture on the paper. So the next thing I do is I just make a reasonable guess. I either double my window or half my window. Okay? Just looking at it, just want to see how good of a guesser you are. Just say out loud whether we should double or half. Say it. Kind of weak, but half. So that means I'm going to go window, change this to half, which would be 2.5, zoom fit again. Remember that while the graph is graphing, if I recognize right away that the window's still not correct, I can always hit the on button to stop the process. So, say again? Oh, you're talking about that. So, still not really what I want, so I'm going to half again. So half of 2, let's go to 1, see how good we get here. There are other ways, but I found that just a couple of guesses and zoom fit is usually good enough. So now I can tell that I have pretty close to what they gave me on the paper. The blue graph isn't quite going far enough. The blue over here needs to come a little further. So I'll make another quick window guess. 1.5 sounds about right. Zoom fit. Anybody need me to talk about anything again? Or come look at your calculator. Or please, Emmy.
You don't have to do it manually.
Hey, look up. Look at the board. This is a really common thing. Look, hey, come on, look up. Don't miss this. This happens all the time. You're pushing buttons, you don't even really notice, and you will accidentally highlight that plot key here. And you'll press enter without even realizing it. Once that plot is turned on, like that, the graphing function no longer works. So you have to get that plot turned back off. That's really common, so watch out for that. Did that fix it, Emmy? Okay. 2 points for Emmy for asking. That's a good question. Anybody else? Oh, please.
Sorry, I missed the last step. What's the window?
So what I ended up, so I just kept guessing, to be honest, Autumn. And the last guess I tried was 1.5. And that worked out pretty good, 0 to 1.5. Is that what you meant?
Yes.
2 points?
Only doing one of the functions up.
points for Nelson. All eyes on me. Come on, look. Don't miss all these little subtle things. These are things that can cause like catastrophe on the calculator section, because if you can't get your calculator to work, you're stuck. You can't do it. Mode button. For calculus, you must always be in radian mode. For calculus, you must always be in radian mode. So radian mode right here. Have to always be in radian mode. Any other problems anyone's having? Anyone need me to come look at their calculator? Okay, I would have done one more thing. Just so I can see a little bit better, I would notice that I am only interested in this portion of the graph here. Just right there. So I don't need to go on the y-axis more than about, I guess this is one, about, looks like 2. So maybe that 2 looks good. So I'm going to go window again. This time I'm going to come down and adjust the y parameter. So I will change y max to 2. Don't zoom fit. Zoom fit changes the y parameters automatically. I don't want the y's changed anymore. I just want to change it to 2. So I just say graph now. So I use zoom fit to get the, adjust the x. When I adjust the y, I don't use zoom fit. Questions? Okay, next thing. I am trying to find this area here. So it's critical that I know this xy coordinate and this xy coordinate. So I'm going to find those. So on my calculator, second, trace, 5 for intersect. It says first curve, I want the blue, so I say yes, I want the blue. It says second curve, do you want the red? Yes, I want the red. It asks me for a guess. That just means the cursor needs to be near the intersection. It does not need to be on top of it. I press enter. I make sure that I see the word intersection here. It's crucial that you see the word intersection. Otherwise, you've done something wrong. So do that. Make sure it says intersection. Wave at me if you need me to come look at your calculator. So it's second, trace, 5 is the intersect. The calculator is going to say first curve, like what curve do you want me to use? So I've got to make sure I am using the correct curve. So I kind of move the cursor a little bit. Oh, yep, that's the one I want. Enter means yes. If it's the wrong curve, you're going to use the arrows to change from curve to curve. But the second curve is the red one. I want that, so I say yes. Guess means put the cursor near the intersection. So I say guess there. And then I just verify that I see the word intersection. 2 for Allison. You wave at me if you need me to come look at your calculator. Whoa. Okay, all eyes up. Come on, focus. Okay, one of the requirements of the calculator section of the AP test is you can never round intermediate values. So this number, 0.902, is not our final answer. But we are going to use that number for a subsequent calculation. Therefore, we have to make sure we store the value. We can't just write it down. We actually need to do both. So let's go back to our paper. Let's make a note here. So right here, I'm going to label this. Again, this is the written section. You must have everything labeled appropriately or you will lose points. So right there, the x coordinate that I'm interested in, that's an x coordinate of, check my calculator, 0.902, always 3 decimals. You should have your calculator set up so it's always reporting 3 decimals. I want to make sure I know where that gets put in my calculator. So I'm going to put, that gets put in A. Therefore, the grader can see that I've stored the value and I don't lose track of where I've stored the value. Questions about anything? It's the written section. You've got to make sure you develop the right habits to write down what's needed, otherwise you will lose points. Test 4 is a written test. It will be graded like the AP test, so no multiple choice on test 4. Okay, so we found that. We need to find this x-coordinate here as well. So we go back to our calculator. This time we're looking for a 0. So this x value, back to here. We go second, trace again. Second trace, come on. We want the 0, which is number 2. It says left bound. First of all, you got to make sure you're on the right curve. I want the 0 of the blue. That makes sense. It says left bound. That means draw a line there to the left of the 0. Now move to the right of the 0. Say yes again to confirm that that's the right bound. Yes means put the cursor near the 0. Make sure the calculator reports the word 0. If you need to see it again, just wave at me. You need to make them look at their calculator.
You're probably going to go over this, but when you say storing value, probably do that on the calculator.
Oh, thank you. I got so excited about 2 points for Daniel. So excited about showing you the 0, I forgot to store it. That was kind of unhelpful. So back here, let's write it down, then we'll store it this time. So 3 decimals, so 1.260. And I'm going to put that into B. And here's how you do that. Okay, you first have to make sure that it's showing on the screen the X that you want to store. Then you hit second quit. Puts you on the main screen. You type X just to verify that you have the right X to be stored. So I remember that I'm trying to store the value of 1.260. So that looks good. Now you simply hit the store key. And then alpha B in this case, because we want that value in B. Calculator will tell you that it stored that value in B. Okay?
Wait. Do that one more.
Huh? We'll do it again. Hey, Daniel, for reminding us about a crucial element of the AP test, which is you must store values. So here it is again. So I'm on the graph screen. I know I need to find this value right here. So that's a 0 of the blue function. So I go second, trace, choose 0. I'm on blue, that's good. I choose the left bound. I choose the right bound. I make my guess. I verify that the calculator says 0. Anybody need me to do that again? Okay, now to store it, I've got to go to the main screen for storage. The main screen can be accessed by typing second quit. Now clear this off. I want to store the X coordinate, not the Y. You can actually store both of them. So I choose X. I press enter to make sure I have the right number. I remember that's the number I'm trying to store. So now I press the store key down here above on, and I say where I want to put it, which is in alpha B. So now anytime I type B on my calculator, it's as if I typed 1.260 with a whole bunch of decimals. Logan, please.
When I put in X and I press enter, it just says X.
Yeah, the Inspire is different. Let me show you on the Inspire, see if this helps. So here's the Inspire all set up. What you have to do is get your cursor to hover over the item you want stored. So I think I can do, I don't use this very often, but let's see if this will work. No? Try this button. Yeah, I don't know if I can get this board to do it. I can do it from my keypad with the mouse. There we go. So see how I've highlighted the 1.260? Now you got to be careful that you only highlight the 1.260. Once that's highlighted, then you can hit the store, which is control the variable key like that. I've already stored it, so I'm guessing that's why it's not working. But on yours it should work. Did you get it to work? I found the Inspire to be kind of a pain until you get used to storing parts. Did it store? Just put it flat so I can see it. We'll be catching the screen. And now I'm just going to work with it. It's really effective. It does have this little part here. It's just really annoying. This part of it is fun. I can never touch it. That's what works out like that, which shows you can put it to a very good value. I think I've got it highlighted. I've tried to store it. So now it's better. See how it shows the variable? No. Yeah. So now we hit the. Let's see how you did it mark. Now try to ensure. And now it did it. So now go back to this screen. Type E. Anybody else? Oh, yeah, go ahead.
Why do we not store the Y value? Why do we only store the X value?
Awesome. Look up. 2 points for Jonathan. He noticed that we only stored the X value. He asked why we did not store the Y value. That will become apparent in a moment. So I haven't really talked about the wheel in a second. So good question. We still need to store this value. I never did store that, so I'm going to put that into A. So I go back to my calculator, back to the graph. I have to calculate the intersection again in order to store it. So same process, second quit. I want to store the X value. The X value that I want is 0.902. Put that in alpha A. Good question. Awesome. Okay, back to the paper. Make sure you have labeled it like this. If you don't have that label showing where you have stored the value, pretty good chance you're going to lose a point on the test. So we're trying to find the area of R. All eyes on me. Come on, look up from your calculator. Look up. Okay, you have to understand the idea, the method of how we find the area so that you can apply this method to all kinds of different problems. Here's the method. Instead of finding this area, what we are going to do instead is we are going to find the area of a narrow rectangle. So I'm now going to draw a narrow rectangle right here. So that line is a narrow rectangle. It has width, it just doesn't have very much width. It also has height. Are you with me? Okay. The width of the rectangle is easy. The width of the rectangle is dx. It's a small difference in 2x coordinates. Because if you could zoom in very, very closely, you would notice that on one side of the rectangle, the x coordinate would be different than the x coordinate on the other side of the rectangle. Therefore, there's a difference in the two x's. That's what dx represents. The difference in the two x's. Questions? That's our rectangle's width. We need the height of the rectangle. This rectangle is touching the function we called g, right here. So I can find the height of the rectangle if I simply know at what x coordinate the rectangle is located. So I'm just making kind of an estimate. Right here is 0.902. Oh, sorry, 1.26. So I'm sitting at about, I don't know, 0.9. Well, actually, that's not right because this is 0.9 here. So I'm more about 0.5. Hold on. So I'm at about an x coordinate of 0.5 for this rectangle. Therefore, that the y coordinate right there, so this y coordinate can be found as the y value is going to be, plug in the x value into the g formula, you get g of 0.5. That's the y coordinate right here. And the y coordinate right there, no, pause there. You need me to go through that again. That's not calculus, that's just math you learned years ago. Talk to me.
I just like blanked out for a second.
No worries. No, it's perfectly fine. Let me get you to say a few things and then it will stick way better. So when we look at this line here, what are we really seeing, Ryan? What I want you to say is we really see a whole bunch of dots. There are so many of them that to our eye it looks like a curve, but there's really just a bunch of dots. Every one of those dots has a y coordinate. Because all of those dots are found using this formula, that means every y coordinate can be found using that formula. So the formula's slogan is plug in an x, find the y, plug in the y, find the x. So all I did is I plugged in x equal 0.5. I plugged that into g. That gives me the y coordinate of this dot right there. I don't know if that helped. Some more? Anybody else? Emmy, please. Awesome. So 2 for Emmy. Right now, I'm not really writing anything for the grader. I'm just trying to make sure that all of us understand what's happening. So writing g of 0.5 I think is actually a better choice, even though they mean the same thing. Please, Jared.
So on the AP test, you're allowed to just like throw out a guess of where you think the x is right there?
So in reality, let me back up. 2 more for Zarin. Okay, I'll kind of focus hard on this. Don't check out on me. Look at me. Look at me. Don't start doing the work. For the AP test, what we've done so far is we were able to get the picture on our calculator. That's essentially, you can't solve the problem without doing that. Then we did a couple of required elements. We found this x coordinate, and we stored that value. We found the other x coordinate and stored that. Those are required elements for the AP test. It's also required that we write down f of x and g of x. We did that. Okay, but now we're not doing anything that's required on the test for a moment. Now we're just trying to get you to understand how this works. Because as always, if you just memorize the process, you are going to fail the AP test. Straight up honest. Like you have to understand the idea. So the idea is, I want to find the area of this odd shape. But instead of finding the area of that shape, I'm going to start by finding the area of one rectangle within that shape. So right now I'm not solving the problem, I'm learning the idea. So I need to know the length and the width of that rectangle. Well, the width is very simple. It's just a very small change in x values. So the width is just some small value. But to find the length, I had to know this y coordinate right here. So that's why I just kind of for this explanation, I said, it doesn't really matter where I'm drawing the rectangle. Let's just pretend I'm drawing the rectangle at x equal 0.5. So here I draw my rectangle. It's very narrow. It's at x equal 0.5. That means that the y coordinate at the top of that rectangle is g of 0.5. That's the y coordinate at the top. 2 for Zara. Other questions? Please, Alice.
How did you know that it was G for and not F?
Oh, only because of how I set up the problem. I remember that when I looked at the problem for the first time, so Allison's question was, how do I know it's G, not F? I am always going to call the topmost function F and the bottommost function G, unless they give me F and G to start with. So I chose this to be F, and I chose this one to be G, and that's why I know this y coordinate is found using the G function. That's your question? 2 more. Be always up here. Come on, don't look away. Like I've seen this happen every single year. Like people kind of get ahead, they go, I figured it out, I got it. They can solve this problem, they can't solve anything else. It's like hopeless. Can you hear? Okay. I need to know this length. Okay, there's a general principle you must memorize. On any graph, the length of any vertical line is always y coordinate at the top, subtract y at the bottom. So please memorize that. The length of any vertical line is always found by taking y at the top, subtract y at the bottom. Always. Doesn't matter where the graph is located, vertical line is always y at the top minus y at the bottom. So I know the length of this rectangle is the y at the top, subtract the y at the bottom. That's the length of the rectangle. The width of the rectangle is dx. So that formula will find the area of one rectangle. One very narrow rectangle located at an x-coordinate of 0.5. Now some people are seeing it. Questions? Please.
So that looks a lot like the Riemann-Son approximation. So like the g of 5 minus 0 is that just the velocity? Or not the velocity, sorry. Is that just the, I guess, I don't know what to call that.
You're doing just fine. There is a relationship between what we did on the buff packet and what we're doing here. It's not exactly what you're thinking, but you're on the right track. We'll just kind of hold that for a second. Okay, I want to find the area of the blue rectangle. Assume the blue rectangle is located at an x-coordinate of 0.4. Assume the blue rectangle is located at an x-coordinate of 0.4. Everybody in the room, let's see who gets it. Raise your hand if you can tell me what would be the formula for finding the area of the blue rectangle. Hands up. What would be the formula for finding the area of the blue rectangle? About half of you. There we go, Elizabeth.
G of 0.4 minus 0.
So that would give me the height of the blue rectangle. I would still need to multiply by the width. And I'm assuming the width is going to be the same for the blue and the green. So I'll multiply by dx again. You raise your hand if you knew that before she said it. 2.3 for Elizabeth. They want me to talk more about it. Please.
So that minus 0, where exactly do we get that minus 0?
Gotcha. So, Logan, how do I don't know this y coordinate, but I can find it.
Yeah.
How do I find that y coordinate?
You would plug in the 0.4 into the equation.
Perfect, perfect, perfect. So this symbol right here is explicitly this y coordinate. You good there? Awesome. What's this y coordinate here?
Oh, exactly.
Does that make sense?
Yeah.
No worries. So I'm just using this. The y at the top, subtract the y at the bottom. 3 points. Anybody else? Cool. So in general, I can find the rectangular area of this brown rectangle. I can find the area of the blue, the green, the pink. There is a general formula, like a formula that will work for any of those rectangles. Raise your hand if you can tell me, what's the general formula for finding the area of any of those rectangles? Like we wrote down that to find the area of the green, it's g of 0.5 minus 0 times dx. To find the area of the blue, it's g of 0.4 multiplied by, minus 0 times dx. What would be the general formula, meaning a formula that has a variable within the formula, so I can find the area of the brown, blue, green, pink, any of them? Hands up. Don't overthink it. It's really easy. Go Jackson.
It would just be g of x minus 0 times d of x.
So I take g of x, that's the y at the top, subtract 0, that's, oh boy, board freaked out. So g of x, that's the y at the top, minus 0, that's the y at the bottom. Okay, hands up if you knew it before he said it. 2 points, 3 for Jackson. Please, David.
There's a problem once you reach 0.902, once you reach that point, it doesn't work.
Nicely said, 3 points. Let me emphasize one other thing before we go there. Okay, please raise your hand and tell me, in this formula, you are allowed to put in any x that you want. What is the purpose of the x in this formula? This formula calculates the area of a narrow rectangle that is within this space here. But what's the purpose of the x in the formula? Hands up. Why is there an x in the formula? Like, you've got to know the reason why. If you don't know why, it's fine, but we've got to learn it now. Daniel.
Just the location of the rectangle that you're finding the area of.
Say it again.
The location of the rectangle you're finding the area of.
Perfect. Daniel, in this space here, how many of these narrow rectangles can I actually draw?
As many as you can fit on the page.
Perfect. As many as I can fit. Each rectangle is identified by a different x coordinate. That's why there's an x in this formula. Because each rectangle is located at a different x coordinate. That's the purpose of the x. How many knew it? Come on, hands. 2 points, 3 for Daniel. Please, Isaac.
In that formula, is it always going to be minus 0?
It's always going to be, when we're finding area, every single time without exception, I'm going to draw my rectangle and identify the y coordinate at the top of the rectangle, y at the bottom. So in this region, the y at the bottom is always 0. It won't be that way necessarily for all problems. Is that your question?
Yeah.
2 points. Anybody else? Please.
I'm sorry, why can't you find the area of the rectangle past 0.902? Because don't you know, like, the width of the rectangle, and wouldn't it not matter? Like, as long as you know the width and the length, couldn't you find the area no matter what?
So let's go here. This is 2 points for Zarin, 2 for David. This is where David was going. Please raise your hand if you can tell me. That orange rectangle is sitting at about x equal 1.1. X equal 1.1. Raise your hand if you can tell me, what is the formula for finding this y coordinate right here? How do I compute that y coordinate? Hands, come on. How do I compute that y coordinate? Let's go, Michael.
f of 1.1 minus 0 times dx.
So that y-coordinate's f of 1.1. That's the y at the top. If I subtract the y at the bottom, multiply by the width of the narrow rectangle, I will have the area of that orange rectangle. Hands up if you know it. Come on, hands. 2 points, 3 for Michael. So, hands up. What's the general formula for finding the area of any of the rectangles over here? Like that orange one or that green one. What's the general formula? And what's the general formula? Jack.
F of x minus 0 times dx.
Okay, I've made a big deal of emphasizing the minus 0. That's so you don't forget that you must always subtract the y at the bottom. However, there is no requirement that you actually write minus 0. Like, minus 0 doesn't do anything, but anyway. How many knew it? 2 points, 3 for Jack. Once again, I know it's kind of redundant, but I need you to say it. What is the purpose of the x in that formula? Hands up, come on. What is the purpose of the x in that formula? Tanner?
It's the location of your rectangle.
Perfect. How many rectangles are there?
Like, means you fit.
Yeah, ideally infinite. Ideally infinite. X tells me which rectangle I'm computing. Okay? Look at me. Come on, look. If it seems simple, that is awesome, because that means it's making sense to you, and you'll be able to use this idea in some future problems that are going to be different, but same concept. But really, the idea is very simple. That box computes the area of any rectangle from x equal 0.902 to x equal 1.260. This formula computes the area of any rectangle from x equals 0 to x equal 1.902. So we have two formulas, one formula for computing some of the rectangles, one formula for computing the other rectangular areas. Questions? Please.
Would you use f or g at exactly the point 0.902? Like, would you use the f or g function?
Really good question. I don't have a great answer. But due to the fact that we are ideally trying to have an infinite number of rectangles, that little question kind of disappears when we go to infinity. That is not a good answer, but that's the best I can tell you. So the good news is for our class, you don't have to worry about it. The math kind of takes care of itself. Okay, look. Reminder. You need to have this on your paper. That's crucial. This is crucial. F and G are required. Everything else that I've written on the paper was just me trying to help you understand the idea. So if I were solving this myself, since I already knew the idea, I would have not had all of that written. Let's make a copy here. So I would get rid of all this stuff. This is all just my explanation. I don't really need any of that. This is all just explanation. And now I just write down the answer. I want to find the area of a whole bunch of rectangles. I can use this formula to find a bunch of rectangular areas. G of x, subtract 0, multiplied by dx. I want to do that computation for many, many x coordinates. Please raise your hand and tell me, what is the first x I want to plug into that formula? Remember, this finds the area of a rectangle. X indicates which rectangle. Hands up. What is the first x I need to plug in? Come on. What is the first x I need to plug in? I've got to find the area of a whole bunch of rectangles. The X indicates which rectangle. What is the first X I need to plug in? Let's go math. And this is kind of like what Logan's asking. We can actually start at 0, works great. Because we want it's an infinitesimal type problem, so we're going to start precisely at 0. That's the first X we want to plug in. X equals 0. Hands up if you knew it. Come on. 2 points, 3 for math. What is the last X for which I want to do that computation? I need to find the area of a bunch of rectangles. What's the last X I need to plug in? Nelson? I just put A. 9.92 is correct. You should just put A on your paper because you've already told the grader that A is 0.902. How many knew it? 2 points. 3 for Nelson. Okay, remember what the integral is going to do. The integral is going to start with X equals 0. It's going to plug that X into the formula and do the multiplication. So it finds the area of the first rectangle. It then will increment X equals 0 to another X. Ideally, infinitesimally close. Hard to talk about it, so I'll just say it goes to 0.01. It then plugs in X equal 0.01, does that computation, that finds the area of the next rectangle. Does that again and again and again until it has found the area of many rectangles, then adds them all together. That's the big S. Oops. Anybody need me to talk through that again? So that integral will find the area of this space right here. Not by finding the area itself, but by finding the area of a million different rectangles and then adding up all the tiny areas. That area is found. But we're supposed to find the area of R, so we've got to say plus. The next formula starts at X equal A. It ends at X equal B. You don't really have to write the X equal. That's just me explaining. Don't forget that parenthesis. You'll lose a point. Those two added together will find the area of R. Question? Please.
So is the 0, since right now you're actually writing what you would on an AP test, you need to put the 0, the minus 0?
You do not. If you do, it's fine. It doesn't hurt anything. 2 points. David.
Is that as far as you need to go on a problem like this?
Close. So this problem on the AP test is actually worth 3 points. By comparison, every multiple choice problem on the AP test is worth 1.25 points. So you can see that this is a pretty valuable problem. There's 108 points total on the AP test. To get a 4, you're trying to get about 55 points. No, wait a minute. About 60.
Sounds like, whoa.
No, that's true. That's not, I'm not kidding. Somebody help me out. What's 55? I need 55% of 108. So 0.55 times 108. What is it, Carl? Yeah, I was right. So if you get 60 points on the AP test, that's typically the lower threshold for a 4.
Wow.
So getting 3 points on this problem, dang, is right. So getting 3 points on this problem, highly valuable. Because it takes, 2.5 multiple choice problems to get the same thing. So far, here's how it will be graded. The grader will say they should be doing 2 integrals. You can't solve the problem without 2 integrals. But I mean, there might be other ways, but this is the way I prefer. So he's looking for 2 integrals. He sees that. He then says, do they have the correct limits for both integrals? 0 and A. You don't have to write X equal. That's just me explaining. So it goes here. He sees a 0. The grader looks and says, A. Did the student tell me the value of A? So if you don't have this written down, you just lost the point. They don't give partial credit.
What if you didn't write the value of A, but you didn't use A? You substituted with the actual number.
if you wrote 0.902 here, as long as when you used your calculator you used A, because you have to use the stored value in your calculator. Otherwise, your final answer won't be accurate enough. The grader will notice, and you'll lose a point for that. So you can do what Daniel just said. You can put 0.902, that's okay, as long as you use the stored value. So what I'm going to push you to do is always put A, because then it reminds you that you should be using the stored value. That's your question. Good point. Okay, grader looks there. Grader looks over here. Again, you don't have to say x equal. If you've got all the right limits, and you remembered to tell the grader the value of A and B, you have earned one of the 3 points. Okay? So you have two integrals. You have the right limits on both integrals. You've remembered to put A and B here. You get one of the 3 points. If you don't have any of that, you just do not get the point. They don't look at it and say, well, you kind of have it, so we'll give you half a point. That's not how it works. Question. Awesome. Next thing. The grader now looks here. This little piece is called the integrand. You should memorize the word, because then when you're learning how to grade the AP test, you'll understand better. So that item here in orange is the integrand of the first integral. This is the integrand of the second integral. When the grader sees those, he's going to say that is correct as long as the student has told me what f and g are equal to. So that's why you must have these two items up here. So if you forgot to write f equals and g equals, you just lost that point. You still get the point for the limits, but you lose the second point. Please. It is. There's no halves. So the problem, 3 points for Elizabeth, since we're talking about 3 points. That's very clever. So the 3 points can be broken down, but not further. So it's 1 point for the limits, 1 point if both integrands are correct. So yes, Elizabeth, if you have one of the integrands correct, but the other is wrong, you lose that point. Does that make sense? Perfect. Anybody else? Now, the last point is they do expect you to run this through your calculator, since it's a calculator allowed problem. So here's how you do it on your calculator. Calculator, main screen. The integral is Math 9. The Inspire is a bit different. If you have trouble, I can come help you in a minute. I need to integrate from 0 to A. Zero to A. I need to integrate the G formula. I remember that I always put G in Y2. So that's alpha, trace, choose Y2. I need a dx. I now need to add that integral to another integral. Now I got to go from A to B. Now I need to integrate Y1. Okay, just wave at me if you need me to show any of that again. Michael, please.
The Y1 part.
So to get the Y1, it's alpha and then trace.
Thank you.
You're welcome. Anybody else? Okay. Look up. Let me tell you what's going to happen. If you already know it, just look at me. Look at me. Look up. Okay, in your calculator, there's a default setting. You don't change the default. It'll mess you up for the AP test. dx is, I believe, 0.00001. So that's dx. That means in this span of x to 0 to x equal 1, the calculator is going to do roughly 10,000 computations. So 10,000 little rectangles. It actually finds the area of 10,000 separate rectangles. And then it adds them all together, but it does it very quickly. 1 second. Okay? That's the area of that space. It's really the area of 10,000 rectangles within, well, 12,000. 12,000 rectangles within that space. That could even be off by a factor of 10. It might be 126,000. I can't remember. Questions?
That's the area.
Please. Let me come look in a second. Look up. Okay, that's the third point. Like you write that down on your paper, correct to 3 decimals. Now you've earned the third point. On the test you take for Unit 4, this problem will be worth 9 points because I'm doing it out of 100 total. And the points don't break down again. It's like you get 3, 3, and 3. So you lose 3 at a time if you're making an error. So it's crucial that as you're practicing the homework, very careful to get things written down correctly. Please.
Are there units? Are there units?
Oh, because no units were specified, you don't need to specify any units either. 2 points. Please.
So, this may be a dumb question, but when we're writing down the answer, do we set it equal to R, or do we set it to equal to area above?
Oh, gotcha. That's not a dumb question at all. They're actually lenient on that one. Like, I don't have to say what I'm finding. They're going to look for the integral. They're going to look for the equal sign. They'll look for this. Good enough. You don't have to say area of R. If you were going to, I would write area of R, though. Look at me. Hey, the pink is not a homework assignment. Unless you want to get started on it, you're welcome to. But there are things in the pink we haven't quite talked about. So what we will do is on Monday, we'll talk about the pink again. And then kind of hoping that basically by the end of Monday, you'll be close enough to having it done that it won't really feel like you have any homework over the break. Does that make sense?
Nope, but I'm doing last.
So since you're so late, you'll have to look at
unit and this
you get
unit
the
at
text
the same
message.
time.
I don't think I
It's all right. What do you got to do? Nothing.
So you can come take that test any day starting at about 12:40. As long as I've told you that I'm going to be here for 2 hours. You don't have to tell me ahead of time. If you need to ask, you can say, oh, you're here for 2 hours, and I'll let you know. But you just show up and apparently it's like the traditional version. So there it is.
Yeah.
You're going to get that score today.
Yeah, so you use the request, right?